Hello and welcome. In this video I'm going to complete a series of tasks for MPLS on OcNOS devices. Specifically, the task speaks about vpls configuration. It says provide vpls compiler service for Alex. So we have Alex here, and let's just start the devices before continuing because I'm going to work on these. And as you can see, I'm using two switches. On OcNOS, of course, switch and router are using the same operating system, so there is no difference between what we are doing, but we are just enabling the switching features in here. Okay, so what we have done in some of the previous videos, which I encourage you to check them out, is we have configured VPWS for the customer ABC, and I'm just referring to that video because I need to speak about some of the features that are important. When we configure vpws, what we do as a matter of fact is we just create some kind of a virtual circuit between two devices. And let me just go with a thicker line so that you can see this better. This is going to be a virtual circuit we just create between R1 and R5. That is a bidirectional tunnel. And I wouldn't call it tunnel, I would call it a virtual circuit, and it is not even a pseudo wire. Pseudo wire is going to be kind of a tunnel which is created dynamically, but overall what we are talking about is a kind of a connection between the two PE devices here, which is going to convey the information from one side to the other side. Let's say that I want to have another provider edge here which is connected to another, let's say, customer location here. What we need to do is to create extra virtual circuits here, and each one of them, of course, is going to be created manually, which means that scalability is going to be an issue, maintenance is going to be an issue. But the thing is, what we do here, we just send information from one side to the other side through these virtual circuits, and we don't have any specific information on the PEs regarding the frames that we receive, regarding the source of the frame, destination of the frame. All we need to do is to make sure that this should go through this virtual circuit to the destination, and we are going to send it to the other side, which means that there is no type of data plane learning in this case. Now, configuring vpls is a little different from vpws. And in which, when we configure vpls, first of all, we are not limited to a certain amount of virtual circuits between two devices. These virtual circuits are pseudo wires, as a matter of fact, not virtual circuits. Pseudo wires are going to be created between these two devices automatically for us, and we are using label for each one of it. It's pretty much similar to vpws, of course, but a little more scalable, in which we create a path from the source to the destination. And when we have multiple provider edge, these paths are going to create some kind of a multi-point to multi-point connection for us. Very different from vpws, in which we have only point-to-point connection. So when we configure vpws, what I'm going to receive is, this is going to be created for me in such a manner, in a multi-point to multi-point channel. I don't have to decide which one is going to be the one to use to get to the destination. What I'm trying to do is to just use a mechanism which you call it flood and learn. Now, flood and learn, of course, is a mechanism in which you check the destination of a frame, very much similar to L2 switch network. And then based on the destination, you decide where to send it. In case you know the destination, then you send it directly to the destination. Let's say that, for example, I know that the destination is going to be on R5, then I'm going to send the frame on this pseudo wire to the destination. If I do not know where the destination is, then I'm going to use flooding. In flooding, what I do is I send it on all pseudo wires, and then the destinations are going to receive, all of the PEs are going to receive this frame. Now the thing is, what can I do to prevent loop? Because if I just go with normal rules of flooding, router 5 is going to receive the frame, and with the default behavior, it will not know the destination perhaps, of course, and in that case it's going to send it to router 3 and maybe back to router 1. Is that acceptable on VPLS or not? There is no such thing as spanning trees. So what we do is we just implement a rule which is very similar to split horizon, in which I say if I have received a frame through a pseudo wire, I'm not going to send it to anyone. Very much similar to IBGP adjacency. If I have received a prefix from an IBGP neighbor, I'm not going to send it to another IBGP neighbor. Here, instead of IBGP, you just replace it with pseudo wire. If I receive a frame through a pseudo wire, I'm not going to send it to other pseudo wires. So router 5 is going to receive it through this pseudo wire, but it's not going to send it to router 3. Router 3 has received it through this pseudo wire. It's not going to send it to router 5. And with this very simple mechanism, we are kind of, understanding how to stop the loops in our network. The other thing is, like I said, we just save some information for here. We are going to save the MAC address here, and very much similar to what we have in a normal switched environment. We want to know where the destination is, or we call it next hop. So we are going to have MAC addresses and next hops saved in our data plane, of course, but not control plane. You know that if we want to go for control plane, there are some other mechanisms that we are going to speak about in some other videos. But here, these are the information that we are going to receive. And based on this, of course, we can just say that these information should have limited amount of our resources consumed. So we can just tell our customers that we are not going to keep more than this amount of MAC addresses for your network, and you have to know about this. But anyway, this kind of configuration is more scalable than VPWS. In this is much better, and most of the configuration is going to be automatic. We don't have to create virtual circuits manually one by one, and also this is very good for customers as well. Okay, so let's do the configuration and see what we have in here. But before doing that, let me do something, because I prefer to have my service provider with some color such as red. I have mistakenly colored this as red, and this is going to confuse you. Let's change the color a little bit. So I'm going to unlock my lab, and then I'm going to change the icon to something like green, perhaps. That would be better. So I'm going to select green for this specific customer. This is not going to be confusing for you. So let me change this one as well. Okay, great. Now it is much better. Let's lock the lab so that we do not accidentally move the devices from one place to another place. Okay, so what we have here is our service provider, which is marked with red, and all the red links here have MPLS enabled on them and LDP enabled on them. Now LDP is going to be used for creation of LSPs, but because the task specifically says that use compiler for this type, in compiler method, what we are going to do is to create some labels using BGP. So BGP is going to be creating the labels for us, and these labels, of course, are going to be what we call it as a BGP signaling for our VPLS neighbor network, and in that, what we do is we just go and add an extra address family to BGP just to create this. So with compiler, labels are going to be created with BGP. We call it signaling, but as a matter of fact, this is kind of a label distribution. So for now, if I check my router 1 and router 5, these three routers in the middle, which are my core, they are not so sophisticated. All they have is just LDP and MPLS enabled on these links. We are not going to do anything with them. The most important part is going to happen on R1 and R5. In my case, these are my provider edges, and let's just take a look at the configuration of them. And in between, I'm going to start this, and I'm going to change, of course, the name for them. So let's go back to R1, for example, and I'm going to say show running configuration so that we can see what we have in here. For now, if I just go for BGP, you can see that I have only one address family enabled for the the PE devices, and that is VPN v4. The rest of the address families, of course, are for each one of my customers separately, and I don't have to do anything about them. And also you can see that on my internal network, I have ISIS enabled. This one, which you can see, this is the ISIS between me and one of my customers, so I don't care about this one. This is important. And on each interface, you can see that I have, on the internal interfaces, of course, I have LDP enabled and MPLS enabled using label switching and enable LDP here. For LDP, if I just go up, you can see that there is a transport address which uses loopback interface. This one, of course, is for previous configuration on VPWS for ABC network, and we don't have anything to do with that either. Okay, so let's start the actual configuration here. And by the way, I'm going to show you one more line of configuration, which starts with MPLS. Here it is, and this is a VPWS virtual circuit that we have created manually. But here, of course, I don't want to do that. Okay, so let's get to the configuration now, and there are two different styles of configuration. One of them, the deprecated version. I'm going to show it to you because that's important to understand this, and after that you're going to see the newer version, which is much simpler, of course, and you can configure it under sub-interface as well. Again, the interface should be in switch port mode. So the first thing that I'm going to create is an MPLS, VPLS, and previously we had VPWS, this one is VPLS, and then I'm going to create a profile for that. So let's say that this is called VPLS, and the name is going to be 15, and after that there should be a number for that. Let's say I'm going to configure this with 15. Now you should know that this number is something that you need to know. There is nothing previously configured with that. If you have configured some other services with this number, then you need to change this number. I previously had VPWS with 15, but I have removed it, and this time this is going to make me no trouble. So under VPLS configuration, there are some configurations that are important for us. For example, VPLS MTU. I don't really want to have any kind of fragmentation for the packets because of the extra overhead that we have for VPLS packets. So what I'm going to do is to decrease this a little bit. So if I just say VPLS MTU, you can see that the number could be anything from 576 up to 65,000, and the default is 1500, sorry. I'm going to set it to 1400. The other thing that I want to configure is based on the prerequisites. I'm going to configure signaling or creating labels using BGP. So I would say signaling is going to be BGP, and under that there are some important configuration. This one is going to be the most important one. VEID is going to be the virtual edge identifier. In this case, this is router 1, so I'm going to configure this as 1. The other side is going to be configured as, let's say, 5, for example. I'm going to exit VPLS configuration. The next thing that I'm going to create, this one is not necessarily with the new type of configuration. So we are going to get rid of service templates later. But for now, I'm just going to go with service template, and let's say this is called VPLS 15, and template is TMP. And under this template, I can select match. And after that, what am I going to match? Am I going to go with outer VLAN for example, trunk, or am I going to use untagged for access interfaces connected to me? Or am I going to have double tagging? Or am I going to use all of them? I can just support all of them, so why not? So I'm just going to say match all. And this is done. Now the next piece of configuration that I need to have is the configuration of the interface itself. So again, this is going to be a little different later. But let's say that the interface which is connected to switch 10 is ETH5. Currently, if I say show run interface ETH5, this has an IP address attached to that, but I don't really want this to be in layer 3, so I'm going to say switch port and then hit enter, and I'm going to say commit for now, so that the configuration that I have done so far is going to be committed. And after making sure that this interface is under switch port configuration, I'm going to say MPLS vpls, and then it asks me the name, and I created vpls underline 15 for this. And then I can specify the service template that I created. vpls underline 15 underline tmp was the name of the template that I created. Now, under this, again, I can have some more configuration. The most important part is going to be this learning, which means that I'm going to have MAC address learning enabled on this device. So I'm going to say learning and then enable, and after that hit enter. And that's almost everything that I want to have on this device. So I'm going to say commit. And after this is done, I'm going to say show run, because I'm going to use this configuration on the other side. So if I just come down to here, this is the template that I have created. So let's say that I'm going to use this one and go to router 5. On router 5, I'm going to say OcNOS, 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 OcNOS. Okay, so after going to configuration mode, I'm going to create this template here. Profile here. This is going to have a VEID of 5. So if I just copy this configuration here, virtual edge ID for router 5 is going to be 5. Let's exit. Exit. And after that, what we need to do is to go for the template. So if I just come down the configuration, there should be this configuration for Ethernet 5, and also something that is not there. I just missed it. I needed to copy that, and that is this one. Okay, so I'm going to use this surface template, and I'm going to put it here. And then the next thing is going to be configuration of interface, which is connected to the neighbor, the client or customer. That was ETH5. In this case, again, interface ETH5. I'm going to say switch port and hit enter. And for now, I'm going to commit the configuration. Then I need to go to here and copy almost everything that we have under Ethernet 5. And that would be this one. Okay, so let's go to here and paste this configuration here, because this is exactly the same as what we have there. Okay, now that I have done this on the two routers, what I'm going to configure is the customer switch 10 and switch 11. Both of them are going to have some kind of configuration. Let's go for that. And because of these weird characters, I'm going to close this session, and also this one, and I'm going to open them again. So this time I'm not going to have any of that format problem here. That's a bug, I guess, in Secure CRT, which I am using right now. So I'm going to say host name is going to be switch 10. Then I'm going to say bridge 1 protocol. Any protocol is okay, but let's say a simple one. And VLAN bridge. Then I'm going to say VLAN 10, maybe 20, 30, 40, and 50. And they are going to be under bridge 1, and states is enabled. And then I need to create some VLAN interfaces perhaps. So I'm going to say interface VLAN 1.10, which is under bridge 1 interface. I'm going to have an IP address of, let's say, 10.10.10.10/24 and commit this configuration. I can create some more VLAN interfaces. For example, let's say that I'm going to have 20 as well, and the IP address could be 20.10, and commit this configuration. And also the interface which goes to the service provider, which is EAT1, is going to be in switch port mode, and it's going to be under bridge 1. It's going to be in trunk mode, so I'm going to say switch port mode is trunk, and switch port trunk allowed VLAN is going to be some list, or let's say all of them. So I'm going to just commit this configuration. So I can just copy these configuration to the other side. So let's say that on switch 11 in global configuration, I'm going to say host name is switch 11. These two commands are going to go there, and basically everything here could be copied. So I'm going to say interface VLAN and an IP address with a little change, of course, and that would be this. And what else? Let's go for this information as well. So I'm going to say interface VLAN 1.20, and IP address is going to be 20.11, and also this interface is going to be trunk. So we are almost done. Nothing else should be there. And now it is time to do some verification, and after that I'm going to show you the newer type of the configuration, which is much easier and it doesn't really need any service template configured on these. So the first thing that I want to do is to say show MPLS on here, on router 1 and router 5, of course. So let's go to this configuration. Show MPLS. You're using vpls and let's say detail. So I'm going to have this detail in here. As you can see, for the detail we have this ID. Signaling is BGP. Route distinguisher is going to use this 100 and then the name of 15. You can see that this is using the BGP autonomous system number and the number that we just gave it to the profile. And route target, the same thing. This is virtual edge ID of 1, and the attachment circuit is up and running right now. And that's almost there. You can see that under this interface we have activated this, and we are accepting almost everything that we really want to. And also, if I run this one more time, I'm going to run this on the other side as well. So if I just go to router 5 and run this, you can see that. Okay, so the other thing that I want to run is show MPLS VPLS mesh. And for now, you don't see any VPLS mesh, and there should be something here that I am missing. As you can see, it doesn't give me any verification of the neighbor, which I have just created here. So I should see a peer in here. So let me see what I am missing here. If I say show run, I have configured some service template and this. And I guess I have done it under the interface. And some, oh yes, here. Something that we did not do is we did not create the VPLS address family under here. I should do it. That is very important. So for that, what I'm going to do is to go to router BGP 100. Then I'm going to create an address family under this, and you can see there are different types of address family. This one specifically is L2 VPN, and after that, as you can see, we have vpls in here. And my neighbor, of course, is 1111, and I'm activating this for this address family. The same thing is going to happen on router 1. So I'm going to say configure terminal, router BGP 100, address family EVPN VPLS, L2 VPN, sorry. Address family L2 VPN VPLS. And my neighbor is going to be 5555, which I'm going to activate it and then commit it here. So let's go back to our verifications one more time. This time I should see something like a mesh. And if I just go back to here, show MPLS VPLS detail. Okay, mesh peer is here. Exactly. That is what I was trying to see it in this part. And the next thing that I'm going to check is MPLS mesh. And let's say the terminal width is going to be more, so that you can see the result much better in here. And you can see that if I just increase this, this is going to go to the place. So we are having a tunnel, and we are having labels created for that, and labels are created using BGP, as you can see in here. And there are some more maybe commands that we can check. Show BGP L2 VPN, yes, exactly. And we have VPLS, and after that, let's say detail. So if I hit enter, this is where we have the in label, the out label, and also the pseudo wire status is established and the virtual circuit is installed. So you can see that our neighbor is 5555, and these are the information that we can see in here. There are lots of different type of information that you can check. And the final verification, of course, is to go to switches and say ping 10, 10, 10, 11 from switch 10. The ping is going through. And if I say 20, the ping is going through. So everything seems to be working. Now let's talk about the new format of the configuration, which is much easier, of course. If I just go back to router 1, and this has logged out for some reason, let's just log in again. OcNOS. I'm going to say en and show run. This time what I'm going to do is to just get rid of this template. I don't really need it. The only piece of configuration that I need is this part, MPLS VPLS, and also the configuration under the BGP for this part. Let's go to here under BGP. You can see that we have this L2 VPN VPLS address family, which is configured for us. Then I need to do this for now. If I just say show run interface 85, I guess, right? Or 4. 85. So if I say show run interface 85, you can see that we have configured this under the interface itself. But if I just remove this configuration, I'm going to say interface 85. I'm going to say no MPLS VPLS 15, and after that service template, this one. So I'm removing this and I'm committing this part, and then I need to configure this under sub interface. So I would say again interface 85. Let's say 123, whatever. And then we are going to have encapsulation of .1Q 123. And then what I need today is switch port. And then I'm going to commit this part of the configuration. Then I'm going to say access if VPLS. And under this, what I need to say is, that's it, MPLS, VPLS, and the name of that. So it was VPLS 15. Then I'm going to say commit. It's going to give me an error here. It says that's basically not the actual error that I'm receiving. The actual error is this is visualization environment that doesn't support subinterface, so the configuration that goes under subinterface is not going to be activated. That's the problem that we have right here. But in actual configuration, you're not going to have such things. So here it says this is an internal error, not because of the error that we have for the configuration, but because of the error that we have for encountering the operation. So that is basically what you are going to do on configuring VPLS on interface or subinterface level. If you just do this kind of a configuration under the interface level, you are going to receive an error that says this kind of information configuration could be done only on subinterface level. So here I'm going to say show transaction current. You can see that I have misspelled show. So that is what you're going to do and add to a subinterface if it is in switch port mode. I hope this has been informative for you, and see you in next videos.